Yo everyone, hope you're all okay. It's time for a Mr. T physics lesson, so I just want to say hey, hope you're all well, and we're going to start a new unit today. We're going to look at energy, radiation, and the universe, okay? So I'm going to expand this now, so my beautiful picture will disappear. Let's get rid of the top as well. Now I've attached this packet of work to Google Classroom. So if you can print it out, because I wanted to write on it, brilliant. Please print it out. If you can't, just have to get some lined paper and answer the questions as we go along using your lined paper. I'm going to ask you to pause at various points and have a go at answering some questions, and then I'll talk you through what the answers would be. This unit is about the transfer of energy and heat, and a little bit about through the universe as well. And the first thing I want us to talk about is something I'm sure you've all heard of, the greenhouse effect. Okay, now, here's a very good diagram explaining it. It's obviously not to scale because the sun is much smaller than the earth in this picture, and we know that is not true. So the greenhouse effect is as follows. The sunlight passes through the atmosphere and warms the earth. Okay. Infrared radiation is given off then by the Earth, and most of it will escape to outer space, allowing the planet to cool. However, some of that infrared radiation is trapped by the gases in the air, by our atmosphere, which keeps the Earth warm and at the right temperature to sustain life. However, and this is the definition of the greenhouse effect, point number 5, increasing levels of CO2, carbon dioxide, will increase the amount of heat retained by the planet Earth, causing the atmosphere and the Earth's surface to heat up, which is of course very dangerous because it affects our ecosystems and melts icebergs, etc., and produces global warming. So that is the process of the greenhouse effect. Now, your first task, having listened to that and seen the notes, I'm going to ask you to press pause in a second, and then I'd like you please to try and number these 5 sentences in the correct order. Okay, so press pause now and try and get those sentences in the correct order. Thank you. Right, coming back. Hopefully you press pause and have a look at those. You should have this one, sentence number 1. Sunlight of short wavelength passes through the atmosphere and warms the Earth. You should have this one for number 2. The warm Earth emits, which means gives off, longer wavelength infrared thermal, which means heat radiation. That's number 2. Number 3, you should have this one. Some of the short wavelength infrared radiation escapes into space. And number 4, the top one, but some of the long wave infrared radiation is trapped by the greenhouse gases in the air, such as carbon dioxide, CO2, methane, and water vapor. And the last one is the middle one there. It's that trapped infrared radiation which heats up the Earth. Okay, so that's the process of the greenhouse effect and how we are getting global warming, and you may need to replicate that on an exam. Okay. Let's have a little look at this next page here. It is a pie chart telling us the sources of greenhouse gases. Okay, so you can see there are 5 main sources that contribute to greenhouse gases: production of electricity, transportation, industry, residential and commercial, which means houses and businesses, and then other non-fossil fuel combustion, so things like maybe a nuclear power plant, for example. And I'd like you now again to press pause in a couple of seconds and have a look at the 4 questions about that pie chart. So press pause now and have a go. Thank you. Okay, coming back. Question 1. What percentage of greenhouse gases is produced by cars, trains, ships, and aeroplanes? Of course, cars, trains, ships, and aeroplanes is transportation. So that's 32%, which is the 3rd largest source of greenhouse gases. But electricity is the first, transportation is the second, and industry is the third. Which fuels do you think account for the greenhouse gases emitted during electricity production? Now, we did production of electricity and energy before. We looked at power stations, and of course that's mainly coal. Okay, coal generally runs the power stations that produce electricity. And the last one, which way of producing electricity does not emit greenhouse gases? And the main ones we spoke about were nuclear, solar panels, wind turbines, hydroelectric, etc. Right? So there's some basic questions that you would get on a test or exam. Right, on to the nitty-gritty of today's lesson, which is about heat transfer. The way that heat is transferred through solids, liquids, and gases, okay? And there are three ways it can happen. One is called conduction, one is called convection, and one is called radiation, okay? And we're going to talk about each of those now in detail. This diagram is a great diagram showing a saucepan with boiling water because it indicates all three types of heat transfer. Conduction is the transfer of heat through the body itself, okay? Convection is the transfer of heat through currents in liquids and gases, and radiation is the transfer of heat through waves through the atmosphere. So let's talk about them in more detail. Right. Conduction is normally associated with solids. Metals are good conductors of heat, while glass and plastic are poor conductors. So conductors means how much heat it can absorb and move. Okay. So I'm sure you've all burnt your hand on the metal handle of a saucepan, or you've all wondered why some handles are made of wood. Well, metals are good conductors and will get very hot, and of course wood or plastic isn't and won't get very hot, or as hot I should say. The heat energy in conduction is transferred from one end of the material to the other, okay, but it always goes, I'll say that again, sorry. Conduction means that if you hold a metal rod in a flame, the end you hold will eventually get hot, right? So if I held this and the flame was over the cold side, eventually it would all heat up and burn my hand. Right, now if we were in school, we would have actually done this experiment. I did it last year with Year 10 last year, and it was hilarious. I couldn't get the Bunsen burners to light. I had to get Miss O'Malley in. Oh, it was a disaster. Right, so here we go. We are going to put a metal rod, and we are going to hang some paper clips that are like stuck on the metal rod by using Vaseline, okay? And we're going to heat the metal rod with a Bunsen burner, and of course due to conduction the heat will transfer across the rod, melt the Vaseline, and the paper clips will drop off. And they should drop off in order A, B, C, D, E, F as the heat moves along the rod. Right, so we'll go through this one together. What happens to the rod just above the Bunsen burner flame? It gets very hot. What is the name of the process that allows heat to transfer along the length of the metal rod? That's called conduction. Right, there's my phone. I'm going to press pause and take this phone call. Hey, I'm back. Sorry about that. Mr. Brown's on the phone. Right, where were we? So, which paperclip, A, B, C, D, E, or F, will fall off first? So, the heat transfers along the rod in this direction. It'll get to A first, melt the Vaseline, and the paperclip A will fall off first, and F will fall off last. Okay, easy peasy. Now, the scientists now do the same experiment and time how long it takes for all the paper clips to fall off using different metal rods. Here are their results. And as you can see, we have, what do we have here? Aluminium, brass, copper, iron, steel, zinc, and glass. And the paper clips took a different amount of time to fall, which shows and tells us that different metals are different at conducting heat. Some conduct more heat than others. And if you look here, glass, the paper clips didn't fall at all, which means glass is a very poor conductor of heat and doesn't conduct heat very well at all. Okay, now I'm going to ask you to pause and spend 30 to 60 seconds trying to answer these four pretty easy questions, and then I'll go through it. Okay, so pause now, please. Right, and we're back. Excuse me. So which material is the best conductor? Now, the best conductor would mean the heat would transfer the quickest and the paper clips would fall off the quickest. So if we're looking here, the quickest time for the paper clips to fall was 29 seconds, and that was copper. So copper is the best conductor. Which material is the best insulator? So that's the opposite. That means the poorest conductor. So the best insulator is the poorest conductor. And that's obviously glass, because they didn't fall at all. If we just look at the ones for where the paper clips did fall, steel was the poorest conductor, or the best insulator, because it took 221 seconds for the paper clips to fall. Now, brass is an alloy, and it's made from copper and zinc. What will happen to the time to fall if the amount of copper is increased? Now, copper is a great conductor, so if I added more copper to my alloy of brass, this time of 92 would decrease. It would become a better conductor. But what if more zinc was put into the alloy? Well, zinc isn't anywhere near as good as copper. Okay, so if I added more zinc, then the amount of time for the paper clips to fall would increase. What do you think the scientists kept the same to ensure a fair test, right? So they'd have to keep the Bunsen burner in the same place, the same height between the flame and the rod each time. And they would have had to have kept the distance between these pegs the same. They would have had to have kept the distance between the paper clips the same. And they would have had to try to use the same amount of Vaseline to stick it on. And obviously the same paper clips, same size and weight paper clips. Right, so that's conduction. That's all about heat transfer in solids. Let's have a look at the next one, which is called convection. And this is about heat transfer in fluids. And fluids is the collective term for a liquid or a gas. Okay? Now, when a fluid is heated, it becomes less dense. That means its molecules move further apart, right? And its volume increases. And less dense fluids will float above more dense fluids. Now, this is basically why we say hot air rises, okay? The hot, less dense air will rise above the cold, more dense air. So let's talk about this hot air balloon. We'll do this as a class, okay? Is the air inside the balloon hotter or colder than the air outside? Well, the air inside the balloon is hotter because it's being heated by the big flame there. So is the air inside the balloon more dense or less dense? It's less dense because when you heat it, that's what happens. It expands, the molecules move further apart from each other, and it becomes less dense. So how do you make it rise? Well, you heat the air inside the balloon so it becomes less dense than the air outside the balloon, and therefore it will rise. How do you make a hot air balloon sink back to the ground? Turn the flame off. The air inside the balloon will cool down until it is the same as the air outside the balloon, and then the weight of the balloon itself will bring it back down. Okay? Easy peasy. So that's convection, and that's the same in liquids as well. So what I'd like you to do now in a moment is pause and have a look at these 3 questions here about an electric radiator. Okay? So press pause now and have 60 seconds on that. Thank you. Right, and we're back. Look at the picture of the electric radiator. Why has the engineer decided to put holes at the top? Right, the whole point of a radiator is to heat the air. The hot air will rise, so you want the holes at the top of the radiator because that's where the hot air will come out of. Where does the cold air go in the radiator to be warmed up? Well, the cold air will go in the bottom, and the heating element then will be in the bottom, heat that cold air, and it will rise and come out of the holes at the top. Label the diagram below, trying to use as many of the keywords as possible to describe convection in a room. Right, oh, I'm sorry, I didn't move down. So we'll have to do this one together as a class. Right, so here's a room. So I have a radiator here in the bottom of the room. And there's a heating element in the radiator, and it heats the air, which makes it become less dense, so it will rise to the top of the room, but it will always go looking for the colder air. So once it gets to the top, it will move around, become colder, become more dense, and start to sink again. It'll sink back to the bottom, head back towards the radiator, and repeat that cycle there. And that is called a convection current. Okay, I'll say it again. That is called a convection current. It also happens in liquids. So if you think of a saucepan of boiling water that we saw at the start of the lesson, the bottom of the saucepan gets very hot, heats the water. The hot water becomes less dense and rises to the top of the saucepan. But then it'll become cooler because it's further away from the heating element. So it'll come back down to the bottom and repeat the cycle. All right, that's called a convection current, and you will need to know that for your test and exam. Last one, well done for staying with me. Last one is called radiation. This is the final type of heat transfer. Now, unlike conduction, which happens in solids, and convection, which happens in liquids and gases that we call fluids, radiation doesn't need any matter, so it doesn't need atoms and molecules to travel, because radiation is an infrared wave. And this is why we can feel the heat from the sun, even though there's the vacuum of space between us, right? So there's no solid, liquid, or gas between us and the sun. It's a vacuum, there's nothing there. But waves, infrared waves in particular, which carry heat, travel between us. Now, the main things you need to know about radiation. Dull black objects will absorb more radiation than shiny white objects. And dull black objects will also emit, which means give out, more heat energy than shiny white objects, right? So think about a matte black box that will absorb a lot of heat and radiate a lot of heat out. But a shiny metal white box, right, if it's shiny, then it will reflect the heat, and any heat within that box, it will be very poor at emitting it. It will stay within, it will be retained in the box. So 3 questions. Why do people living in Spain or Greece often paint their houses white? Well, because it's very, very hot in Spain or Greece, and you don't want your house becoming very, very hot. You want it to be cool. So if you paint it white, it will reflect the sun's heat. Why are solar panels often black? Well, the purpose of a solar panel is to absorb as much heat as possible to convert it into electricity. So if they're black, it will absorb more of the sun's heat. Why are people suffering from hypothermia often wrapped in a foil blanket, right? So if you wrap them in a foil blanket, then the heat they do have and are emitting will be retained, and they won't lose that heat themselves, so they can warm themselves up. So your next task, I'll ask you to press pause in a minute. Have a look at this sentence here, and can you please put the right words in the right gaps there? Off you go, press pause. Thank you. Right, and we're back, and the answers were: heat can be transferred by radiation through a vacuum. Radiation is a wave and does not need particles to transfer heat. Infrared radiation is absorbed by dull, rough and dark surfaces. However, infrared radiation is reflected by shiny, light and smooth surfaces. I'm sure you got that right, and well done if you did. Right, we're very much nearly there now. Last 2 minutes. So let's have a look at this question here. Scientists paint one side of a cube black and another side of the cube white. They then fill up the cube with hot water and place one thermometer 5 centimeters away from the black side and another thermometer 5 centimeters away from the white side. Press pause now, please, and have a little go at answering those questions there. Thank you. Right, and we're back. So how do the scientists ensure a fair test? Well, they just make sure these distances of the thermometer are the same from each side of the cube. After 1 minute, the scientists look at the thermometers. Which thermometer will show the highest temperature? Well, the black side will emit more heat than the white side. So this thermometer here by the black side will have the highest temperature. And that's the explanation as well. Black is a better emitter of heat. If you were going to heat the water in the cube by putting it near a Bunsen burner, which side would you place facing the flame? Well, again, you'd go for the black because the black is also a better absorber of heat. So if I put the flame by the black side, it would absorb more heat and then heat the water quicker. And there's my explanation to that as well. I hope you had something similar. So here's like an exam question, right? So list A here, there are 4 situations where heat is transferred. And then the list B are the 3 types of heat transfer: conduction, convection, radiation. Draw a line from each box to describe which type of heat transfer is going on. So press pause now and have a go at that, please. Thank you. Right, and we're back. So this was quite easy. From the sun to a roof-mounted solar panel. That's radiation, right? So heat coming from the sun is radiation. From an electrical hot plate through the base of a metal saucepan. So you've got the 2 solids touching each other. So that heat transfer is conduction. From the element of an electric kettle to heat all the water in the kettle. So this will be convection. It will create that convection current. Heat the water around it, that will rise and cause that convection current. And from a fire to a person sitting directly in front of it. Well, hopefully that won't be conduction, because that means you are actually in the fire, which could burn and be slightly dangerous. Okay, so you would feel most of the heat from the fire from radiation. But of course also, this was a bit of a trick question, the fire will heat the air in the room using convection, and that will also make you hot as well. So they were the answers to those. That's why it was worth 4 marks. Right. So well done for sticking at it, kids. Very proud if you did. Here are the just everything we've just been through in a nutshell, like the revision notes you would need about conduction, convection, and radiation. I'm certainly not going to read through it. Don't forget, we also spoke at the start about the greenhouse effect. So make sure you learn those 5 processes of how we have global warming due to the greenhouse effect. Learn your definitions of conduction, convection, and radiation, and then look out for a quiz that I'll be posting on this soon. All right, I hope you're all well. Please take care. Any problems, get in touch, and I'll speak to you very soon. So I'm waving bye-bye.